Welcome back to Learn Fast with RK. In this session, I am going to explain you how we can perform the temperature analysis use case using one-dimensional array operations in C programming. In this session, let us learn how we can perform the operations of one-dimensional arrays using the use case of the temperature analysis. The objective of this use case is we have to write a C program which reads the temperatures in a place for a weekdays and perform the analysis. The analysis report includes displaying all the temperatures of the weekdays, finding the maximum temperature, minimum temperature, average temperature, sum of the temperature, and the statistical analysis parameters such as standard deviation and then variance. Let me introduce you what is this standard deviation. A standard deviation is a measure how our data is spread. It is represented using the Greek letter sigma. In order to calculate the standard deviation, we need to calculate the variance and then perform square root over this variance. The variance is the average squared difference from the mean. So this is our objective for this use case, temperature analysis. In order to perform this task, let us see what are the things that we need to consider. To read the temperature for 1 week, we need to use 7 variables. Let us see how arrays can simplify this task for us. Let us find out the difference between the variable and an array first. For reading the temperature of the weekdays, we may need of 7 variables. Day 1. One variable can hold only one value because we need to perform the analysis over 7 days temperature. Here we need to have 7 different variables. Suppose we need to perform the temperature analysis over 100 days. Then how many variables will we declare? Probably day 1 to day 100 variables. The things will get worse and even further if the temperature analysis to be performed over 1000 days. Now what we have to do is a big question mark for us. Let me introduce you a small recap of what is an array. So an array is a collection of homogeneous elements. Homogeneous elements means all the elements in this array should be of the same data type. Here day 1 to day 7 all are of the type integer. So we can make use of this arrays concept. By this declaration of this day 7, simply replace this variable with one single variable, temperature, and then how many elements we need to store? We need to embed that within the square brackets, size. Here the total number of the elements that we need to store are 7. Here we can replace this to 7. Just see how simply we can declare a variable which can hold 7 different values using one single variable name. So this is the simplicity of an array. Just think, if it is 100 variables, simply only one single thing that we need to change will be, instead of 7, we need to change that to 100. We need to change that to 100. If it is 1000 variables, then the size will be 1000. Nothing will vary. So one single variable can hold these many number of elements of the similar data type which we declare here. Let me show you what will happen inside the memory when you declare an array of int temp of 7. Let us assume this is our memory model. In a 32-bit processor, each of the integer variable will occupy 2 bytes of the memory. So this is 2 bytes of the memory, this is another 2 bytes of the memory, this is another 2 bytes of the memory. So whenever we declare temp of 7, 7 locations have to be created. So now these 7 locations are allocated with a single variable name temp. You can imagine what will happen if you declare a temp of 7. How can we access individual elements of this 7? By using temp? Not at all. Then each of the array element can uniquely identified by a separate variable called as an index. Index is an integer which always starts with 0 and ends with a n-1. For the temperature, we have created the 7 memory locations. Hence the index of this temperature variable starts with 0 and ends with 6. Now the first element in this temperature variable will be indexed as temp of 0. Similarly, the rest of the elements are also indexed. Now temperature can hold totally 7 elements. The index starts with 0 and ends with 6. The first element will be stored in the 0th location. Second element will be stored at 1, vice versa. Nth element will be stored at n-1. Let me tell you a small difference between normal variable and an array variable. A normal variable, when you create 7 different variables, all the memory locations allocated for these 7 variables need not to be the contiguous locations. For example, day 1 may be allocated here, day 2 may be allocated here, day 3 may be allocated here. Likewise, it will allocate the 2 bytes for each of the memory location in a different places. Let us see the advantage of the locating all the memory locations contiguously in further session. So an array is a collection of the homogeneous elements. Here all the elements are of the same data type, integer, and allocated all the memory locations continuously. If at all, if it is 100, then all the 100 locations are also located contiguously. Our next job is to read the temperatures for weekdays. In order to read the temperatures for the weekdays, normally we can use the scanf function. In order to read the first element in the temperature, we have to make use of the scanf, the format specifier %d, because the temperature variable is an integer variable, and in order to refer to the first element, we need to make use of the index 0. So here we need to mention the ampersand temp of 0. Likewise, we need to write down for all the 7 variables, we need to write down 7 scanf statements, or in one single scanf statements we need to make use of the 7 different variables: ampersand temp 0, temp 1, temp 2, temp 3, temp 4, temp 5, temp 6. This would be easy in the case when we are having the very little number of elements in an array. But suppose if we are having 100 elements in an array, just guess what will happen. The things will get worsened. So in order to perform repeatedly the similar task, we will be make using of the looping statements. Here for the array, for loop will be best fit. Why? Because it is a counter control logic and an index can be operated easily in the counter control logic. Let us write down a small loop and read all the 7 elements using one single looping statement. In order to use this loop, we need to make use of the counter. So now I am declaring one more variable, counter, I equal to 0, I less than 7, I plus plus. Let me explain you clearly why I have initialized this I with 0, because the first element in the temperature will stored in the location 0 and last element will be stored at 6. Hence I am just writing down for loop. If you write just like this, it will read 7 times the element into the first location. But now our requirement is to read 7 locations in the 7 different elements. I just simply replace this 0 with I. I will initialize it with 0, and because it is less than 7, enters into the loop, reads one value and stores in a temp of 0. For example, let us give the 10 and temp of 0. Similarly, we can continue further, read the second element, increment I by 1. Now I value will become 1, less than 7. Then again it reads the value. After reading the value, then again it will get stored in temp of 1. Let us say it is 20. Similarly, let us finish all this loop for the 7 iterations. In the temp of 2, it would be 30, 25, 21, 5 and 7. So after this 6, then again it will try to enter into the loop. But whereas in for loop is an entry control looping statement, it will check the condition before it enters into the loop. Here 7 is less than 7 is a false statement, then it will go to the next statement. So we have performed the first task of reading the temperatures. After reading the temperatures, as per our problem statement, the first task is to display all the temperatures. In order to display all the temperatures, we can make use of the similar kind of a looping statement here. So we need to display the elements. In order to display the element, we will use the printf statement. Normally printf %d comma temp of 0. To print the second element, then you need to write down the printf %d temp of 1. Third element temp of 2. Fourth element temp of 3. Likewise until temp of 6. Because our array contains the 7 elements, we have to repeat. We are performing the repeated task Instead of that, what we can do, simply we can write this statement in a for loop. You can also make use of the while loop statement, but for loop will be very easily adaptable to the array kind of the operations, because it is having an index to point, and then here I am mentioning for I equal to 0, I less than 7, I plus plus. Now let me explain you what will happen in this case. Initially I is started at location 0. Now it will check whether the 0 is less than 7 or not. Because 0 is less than 7, it enters into the loop and it tries to print a percentage d temp of 0, means it will only print the one element for all the 7 iterations. So I need to replace this with an index. I value is 0 because the temp of 0, the element in the temp of 0 is 10. Then it fetches this 10 value and displays that in the output screen. After displaying that, then again it will enter into the loop and then increment the value by 1. Now I value will become as an 1. 1 is less than 7. Then it tries to print temp of 1. The value in the temp of 1 is 20. Hence it will print the 20. I will become 2. 2 less than 7 true. Then it will print the temp of 2. The temp of 2 is 30. Similarly it will print 25, 21, 5 and then 7. Then it will become 7. 7 is less than 7 is false. Hence it will stop the process and displays. It is always better to write down a program in the incremental fashion. Let us execute this program and check. So our program is asking to enter the 7 values. So I am entering the values 10, 20, 30, 40, 50, 60 and 70. All these values will be stored in temp of 0, temp of 1, temp of 2, temp of 3, temp of 4, temp of 5 and temp of 6, and it is displaying all the values. Here I didn't mention any format specifier like \n or space. So because of that, the output is just like that. Let us format it later, but our program is functioning well till now. The next task is to find the maximum temperature. In order to find out the maximum temperature, we will follow the algorithm just like this. First of all, what we need to do, we need to read the temperatures into the array. After that, we need to take an additional variable which is called as a maximum. We need to initialize this maximum as a negative number. Why? Because I will explain you later. And now every time we need to iterate in the loop and check whether any number is greater than maximum or not. If any number is greater than maximum during the iteration, then we need to update this maximum value with an updated maximum value of this array. After iterating all these elements, the maximum will hold the maximum value of an array. Let me explain you using the memory model. So we have all these 7 elements and we are declaring a new variable which is called as a maximum here. Initially we need to store some negative value minus 2200. Now what we need to do, we need to iterate in the loop. First we will check with the temperature of 0. The temperature of the 0 is 10 and then maximum value is minus 2200. The temperature value is greater than maximum. Hence what we need to do, we need to update this maximum value by 10 by the temp of 0. The temp of 0 is 10, so we need to change the value of the maximum as 10. Now we will go to the next value in the loop. The temp of 1 holds the 20. Till now the maximum is 10. We will compare the temp of 1 with the maximum. Temp of 1 is greater than the maximum. Hence we will update the maximum by 20. Similarly we will repeat this loop. The next value is 30. 30 is greater than 20. Hence we will update the maximum. Similarly we will go to the next value 25. But the 25 is not greater than 30. Hence nothing will happen. Go to the next value. 21 is also less than 30. No updation. 5 is also not greater than 30, hence no updation. 7 is also not greater than 30, hence there is no updation. After all the iteration, then the maximum value that will return will be 30. This is how the maximum finding algorithm will work. Let us implement this using the C code. Already we have completed reading all the elements. We need not to write down that step. Iteration loop to find the maximum. This block of the statement is to print the temperatures, and to find the maximum we need to have an additional variable maximum. So as I already told you here, suppose if we initialize this maximum with some 10,000, then none of this value in the array is greater than this 10,000, hence it will give us a wrong output. So for this reason only we are initializing this maximum variable with a negative value. Now we need to use a variable called as an maximum, max, initialized with some negative value minus. So make sure that there is no other element is less than this maximum. We are also having one more optimization. We will start initializing this maximum as an first value, and we can also iterate. This thing we can do it as an optimization step later. Now we need to write down the iteration statement here. So for I equal to 0, I less than 7. 7 why? Because the maximum number of elements in the temperature are 7, hence we need to iterate the loop with the 7. Now I plus plus. We need to check for every element whether any element is greater than the maximum, then we maximum value. The element value which is represented like temp of I need not to tell again what is this temp of I, we already discussed in the earlier session, whether it is greater than maximum or not. If at all, if the element present in the array is greater than the maximum, then we need to update the maximum with a new value. So max equal to the updated value temp of I. So we completed this block. After this block we are just printing the value. Here we can also do some of the formatting. Previously also we forgot to use the formatting. In order to make it much beautiful here, let me add some printf statement. Printf enter %d value and /t, and we can use the \n. It is always preferred to use a proper display statement or remove the confusion for the user which value that he has to enter. And here I plus 1. Why? Because the index starts with 0. We are iterating just like this, and after this /d. Otherwise we can simply use /t. So that all the values can be displayed in one single line. So let us write down this program. Semicolon is not there. Done. Always every executable statement in the C language must end with a semicolon. Here also I forgot to use this. Now now in the previous case we have very blank screen that the user will get confused what to enter and then how to enter. So now here the display is very comfortable. I am entering the value 10, 20, 40, 21, 5, 9, 7. So all the 7 elements are over. Now the next step is to display all the 10 elements. It is displaying 10, 20, 40, 21, 5, 9, 7, and among all this obviously the maximum value is 40, hence our program is working fine. So this is how we have implemented the algorithm to find the maximum of an array. Similarly, the next task in this is to find out the minimum temperature. In order to find out the minimum temperature, we will use the similar kind of the algorithm, but only one simple change that we would be using will be instead of the greater than value we need to perform the less than value. Other than that it will work similar like. So let us go through this algorithm once. First we need to read all the temperatures, then we need to initialize this minimum with some larger number. Otherwise we can also optimize this algorithm by assigning with the first array value, and next we need to iterate through the loop, and if you find any element in the array which is less than minimum, then we need to update this minimum. Let us understand this algorithm through the memory model. We already had this maximum. Now let me allocate one more variable, minimum. The minimum variable is allocated with the 2 bytes of the memory. Name it as minimum, and initially some maximum value 10,000 I am inserting here. Instead of that, you can also initialize with the temp of 0, which is 10. Now what will happen during the iterations of the loop? First it will compare the first element with the minimum. The first element in the temperature array is 10, and the value in the minimum is 10,000. Hence it will compare both of the things. Since the temperature of 0 is less than minimum, now we need to update this minimum with that value. Updated value in the minimum will be 10. Similarly, we will iterate in the loop. Next it will go to the temp of 1. Here the temp of 1 storing 20, the minimum is 10, temp of 1 is greater than minimum, so no updation in the minimum. For 30 also no updation, for 25 also no updation, for 21 is also no updation. For 5 is less than 10, hence we will update this minimum as 5. Similarly, we will check for this temp of 6. 7 is not less than 5, hence we will terminate this loop. After complete iteration, the value stored in the minimum will be 5. So now I think from the analogy you can easily guess why we have initialized this minimum with a higher value. Yes, you are right. So let us write down the program for it. Let us write down the implementation for this algorithm. We already completed the reading of the values. For finding out the minimum, find minimum for I equal to 0, I less than 7. It is very easy case. Every time we will be using the similar kind of the loop. Now inside this, before that we need to initialize the minimum, and we need to declare min equal to let us start with a temp of 0 initially. This is another initialization kind of a thing, and here comma min without any confusion, min. I am just comparing if temp of I. Why? Because every time it needs to iterate and then obtain the next value in the loop. If we mention any of the static values such as 0, 1, 2, it will only compare with the one value. Now here the temp of I, if it is less than minimum only, then we need to update the value. Greater than equal to or greater than case, we should not update the value. So now minimum equal to the given temp of I. After this entire process, we need to print the minimum of that. So I am just writing down the minimum is stored in the variable min. So I read the values and initialize the minimum with the temp of 0. In previous case we took a larger value or smaller value. All these are all a bit of confusion, but for the understanding sake I just explain you why we need to store the larger value or the smaller value. We can also do that in this way. Let us find out whether our code that we wrote for finding out the minimum of all the temperatures is working or not. 25, 31, 24, 9, 48, 55 and 24, 22. So hence from this we can easily find out the minimum among this should be 9 and then maximum among all this should be 55. If we got that answers, then our algorithm is working fine. So it printed all the values, then after that it find out the maximum as 55 and then minimum as 9. Hence our program is working fine. We completed 3 of the tasks from the problem. Now let us go and then find out what is the next task. Our next task is to find the average of the temperature and the sum of the temperature. I think the sum and the average both are interrelated. First, in order to calculate the average, we need to find out the sum, and after that only we will perform the average. I think we can merge these two together and write in one single loop. But to find out how we can perform the sum of n numbers, let us use this algorithm. Initially we initialize sum with 0 and add every element to the sum. Let me explain you using this memory model. So I just initialize the sum as sum equal to sum. Initially it is stored with 0 and we will iterate from the loop. The first value is 10. Now the sum will update like 0 plus 10, which is 10. Now after the iteration, second iteration, that would be 10 plus 20, 30. And then after third iteration, 30 plus 30, 60. And then 60 plus 25, 85. And then 85 plus 21, 106. 106 plus 5, 111. 111 plus 7, it is 118. So by the end of all the iteration of this looping statement, the total sum value will be 118. In the sum, it will store 118. We should calculate the average of it. Since the average is an decimal point, if we use the integer division, then that may result in loss of precision. So what we can do, floating variable declaration. So in the floating variable declaration in a 32-bit compiler, it will allocate 4 bytes of the memory for a floating value. So since we can take one variable average as a floating variable, and what we need to do, we need to perform the sum by n. Here the sum value is 118, the 7. If you mention the 7, then it will return in integer division. So we need to mention 7.0. Why? Because we need to perform the typecasting. What is this typecasting? I will definitely cover in the next sessions. For the time being, n should be of the floating value. Otherwise, we need to convert this whole result in a floating value. So in this way, what we can do, we can find out both the average and the sum using one single loop. Code for this implementation. 2 additional variables are required. One is sum, other one is average, but the average is of the floating type. Since that, so float average. So initially I am just initializing value, sum equal to 0 and then average equal to, let us say, 0. I iterate through the loop. Always remember, in order to access every element in the array, we need to write down for loop, which is an easy way of accessing. Even if it is having the 100 elements, simply one for loop will help us to read all the 100 elements or to display all the 100 elements using one single for loop. Here, add every element to the sum. So sum plus equal to temp of I. After this loop, it could able to find out the sum of all the array elements, and we need to find out the average equal to float of, we need to write down, this is the entire thing is a float type conversion of sum by 7. So now average is stored with an average of the value, sum is stored with the sum of the value. So in order to print both the values, because the sum of the integer values is %d itself, comma sum, and in the next line average equal to %f. It is always use a proper formatting. I will tell you after the end of this session. So sum, we are able to get it or not. Let me give with values, some random values I am inputting here, 21, 4, 6, 8, 2, 4, 8, 4. These are all the different elements that we stored. Here the maximum is 21, minimum is 2. I think we need not to check it for again. The sum of all these values are 53. Since the sum is 53, 53 by 7 would be 7.57. Now we are left with only 2 more tasks in this problem statement to find out the standard deviation and then variance. These two are also interrelated. A single loop is enough to repeat all these things. In order to calculate the standard deviation, we need to calculate what is the variance. So in order to calculate the variance, we require the mean. Already we completed finding out the mean. Our mean is already located in average. We need to square up the difference between the temperature value and then mean. So let us see what is the algorithm for it. So this is the algorithm to find out the variance. First we will calculate the average. This is already done. Now we need to iterate through the loop and find out the difference of every individual number with the average and store it in a difference variable and find out the sum of squared difference. Here difference has to be multiplied with the difference itself to find out the square of the difference, and then we need to store it in a SSD. Now let us see what is happening inside our memory. So we need to declare a difference variable and then SSD squared difference. So difference will always find out the difference between, okay, now let us take the example with the input values 30, 20, 80, 40, 50, 60 and 70. The sum will become 350, average will be 50. In the first case, what we need to do, we need to find out the difference. 50 minus 30, that will become as in 20, and then this 20 we need to find out the square value and add that to the sum of the squared value. Now this will become as in 400. Now again, what we need to do, we need to consider the next case, which is temp of 1. The value in the temp of 1 is 20. The average is, since the average value is 50, 50 minus 20 we need to do, and then the difference will be 30, and then we need to add 400 plus 30 into 30, which is 900. Now this will become as in 1300. So we will repeat this process for all the 7 elements in the array. Finally we will find out the sum of the square difference value SSD in this. Variance as average of the sum of the square difference, which is sum of the square difference by n, which is equal to var, and then we will display the variance. This variance can be input to our calculation of the standard deviation function. Standard deviation is calculated as the square root of the variance fed as an input to this. Let us write the program for it. The additional variables for finding out the difference, sum of square difference, sum of the square difference, variance, and then standard deviation. So in order to do that, we will declare 4 variables. As all of them, let us declare as an float value, difference, sum of square difference, average value, variance, standard deviation. So I just created all the values. So initially I am initializing the sum of the square difference as 0. First let us write down that for loop. Since the average is there in average variable, so what we need to calculate, the diff equal to average minus temp of 5. So we find out the difference between every individual element and then average. And after finding out this difference, what we have to do is we should square this difference and add that to the sum of the square difference. So SSD plus equal to diff square. Diff square we can perform in 2 ways. Directly we can write on the diff multiplied by diff, otherwise we can also use math function, which is a power function. Now this is what we done for finding out the sum of the square difference. After the end of this loop, we will calculate the variance equal to SSD by n. So we completed this variance, and after this variance we will calculate the standard deviation as a square root of the variance. In order to write down the square root, we have a function called as an sqrt. This sqrt function we are having in the math.h. So we need to include #include math.h. Since we are using the square root function, it will return a double value. I think we need to convert that into floating value. Variance we will give as an input. Since the square root function will give the return double, now I am converting into float. This is called as an external typecasting, putting the larger data type into smaller data type. So after calculating this variance and then standard deviation, we need to display variance equal to %f. Let me execute this code and check. Now let us execute the code and check. 10, 20, 30, 40, 50, 60, 70. As simple as that. The variance is 400, and then standard deviation is the square root of the 400, which is 20. Average is 40, and then sum is 280, maximum is 70, minimum is 10. So this is how we have completed all the tasks for the analysis of the temperature. And let us optimize this whole code. So what we can do, instead of writing down many of these things, we can club some of the tasks together. That is how in this session we solve our problem of the weekly temperature analysis. Display numbers, maximum, minimum, finding the sum and then average, and then calculated the standard deviation and then variance, and we optimize this code in a newer program just by condensing that into normal for loops. But why should we condense this program, and what is the advantage of this condensing of this program? So I just wanted to show you with one example. Instead of the reading, I just commenting this reading section and initializing this array by value. Similarly, I am also commenting a normal code reading section and initializing with some array of the elements. So an array can be initialized by using the comma separated values within the braces, just like this. To see what is the performance difference between the normally written program with these many number of for loops and condensed program with. So let us see the difference between these two. First, let us execute a normal program and check how much time it is taking. If it is already supplied with the data, then it is taking 0.134 seconds. Let us now execute a optimized program with less number of the for loops. Run this program and check. It has taken only 0.103 seconds. So this is how we can minimize the number of steps that we included. And I would like to tell you some more optimization things, important techniques that we need to use. Never hard code your program. That means here the temperature is 7. If you write down like this program is only fit for code where we are having only 7 days week temperature kind of an approach. For example, if you want to generalize this, you can declare this variable as 100 and read the number of the days, and then you just replace this entire code. Instead of the 7, you just change that to n. If you do like that, then based on the number of days that you input, those many number of inputs that will take and then perform the action accordingly. That is always better. So you should add some sort of the dynamism to your coding. We have to minimize the number of the for loops that we will use. Wherever it is necessary, we can condense and then remove certain for loops where the common task that is performed. But displaying the output in the desired fashion is also important, so we have to have that idea also in our mind. So with this, we finish the weekly temperature analysis. That is all in this session. Based on this, you can also perform one assignment of the student marks analysis. So read 70 student marks and then find out such as who got the maximum marks, minimum marks, what is the class average, what is the sum of all the marks, what is the standard deviation, what is the variance. Likewise, you can perform the student marks analysis. If you could able to perform this task, please write that code in the comment section. I am also attaching both the codes for the normal writing of this program and then optimized writing of this program in the description section below. Thank you for listening to this session. If you like this video, please like, share. Don't miss any update from this channel. Click on the bell button and subscribe now.